Hi, I'm Blake Sandlin, Irrigation and Soils Farm Advisor from Kern County, and we're trying to put together a fairly straightforward view on optimal irrigation scheduling and monitoring for pistachios. While the bulk of this boils down to a lot of work on your hands and knees to make sure the system's running right, a little prayer sure doesn't hurt at all. As anybody knows who's out there trying to farm the variable soils we have in the San Joaquin Valley, you have everything from sodic, silty spots with chromium infiltration to beautiful sandy loam or sandy clay loam ground, like in this lower left-hand corner, that provides for beautiful trees. What our job is to integrate the soil texture, water holding capacity, salinity of the water and the soil, the irrigation system capabilities, and the rooting depth of the crop to come up with the perfect irrigation schedule. To understand where the water goes and exactly how much you're going to store, you need some tools. Simple auger bits like this are absolutely essential for getting a feel, literally a feel, of how much the soil can hold moisture-wise and what kind of layers you're going to find within that soil. A 3-foot push probe can be an easy way to get down into the appropriate layers in the root zone in a reasonably friable sandy loam. Understanding just where you have significant layers will give you an estimate of where your roots are concentrated. If you're not familiar with the Almond Board of California's Almond Irrigation Improvement Continuum, I would encourage you to go to their website. They have probably the largest collection of helpful irrigation information of any commodity in California at this time. And the 4 main points: getting it in, getting it uniform, getting the right timing, getting the right amount, are the critical elements to understanding soil moisture and perfect irrigation scheduling. At the simplest level, understanding irrigation scheduling is just knowing how big your cup is. So, depending on the soil moisture texture, depending on drip irrigation system, micro sprinkler, flood, how quickly you can replace that water, you need an estimate of how much water the plant's going to use over the week, which you can see on the right-hand side of this illustration, and then just how much can your irrigation system apply in 12 hours, 24 hours, and how much allowable depletion is in that soil profile before you hit the wall in terms of actual stress. This is an actual electron micrograph of stomata on the underside of a leaf. Basically, these are the portholes where water vapor leaves the tree and where carbon dioxide comes in to make the carbohydrates. When stress occurs in the plants, these stomata collapse, as you see in the picture on the upper right, which now means that the tree is going to heat up, it's not blowing off water vapor, and you reduce the amount of carbon dioxide uptake for making sugars and nuts. This somewhat complicated looking graph is actually from a capacitance soil moisture monitoring setup where there is a sensor at the 4-inch depth, 8-inch, 12-inch, 20-inch, and 36 inches. You can see these designated on the left-hand side. And if you will notice, down to 12 inches, there are very significant bumps when you have 4 hours of irrigation, 6 hours of irrigation, a rainfall event near May 20th, And then there's a steep drop during the day and a flat stair step at night when the stomata close, because the stomata are also keyed into light versus dark conditions. And at night they close down and the plant stops extracting water. And ultimately in this graph, if you look at the 36-inch sensor on the bottom, you can see there is no activity of either percolating water nor uptake from the plant. All the water is coming in and out of the 3-foot depth in this particular chart. We have 3 different areas we're focusing on for this pistachio irrigation monitoring project, going from the west side near Coalinga to near the Lemoore Naval Air Base, sort of midwestern valley in the saline area, over to east side, typical sandy loam soil near the intersection of Highway 198 and 99. These different sites provide us a considerable difference in terms of the native salt load that the trees have to grow underneath, and provide an opportunity to look at, well, how does that affect my decision making for irrigation scheduling? This particular slide has an excessive amount of arrows to try and indicate to you the type of monitoring devices we have at each of these 3 different sites. Starting in the upper left-hand corner, you can see a Phytech Bluetooth dendrometer that gives an indication of the shrink and swell of the tree during the day. Dropping down below that is a Centec drill and drop capacitance probe, which is connected to a Jane logic system, formerly PureSense, that you can see on the tower going kind of up the middle of the slide. Then we have a collection of aerometer tensiometers and watermarks you see in the lower right-hand corner. These are at the 18, 36, and 48-inch depth. The watermarks are an electrical conductance device that changes an estimated soil moisture tension based on the conductivity by increasing or decreasing water capacity, water volume. And the tensiometers, of course, measure the actual tension with which water is held within the soil. And then you look in the very middle of this picture, you can see a tower that has a number of meteorologic instruments that are outside of this picture, which are measuring the water vapor flux leaving the orchard. In other words, ET. And then over at the far right-hand side, you can see the one arrow indicating the 9-foot deep neutron probe access tube. The Phytech dendrometers and the Centec drill and drop capacitance Jane logic are giving us real-time information on the web. The aerometer logger has to be downloaded manually. Now we will quickly review the various sites as they vary by salinity and soil type. This is a picture of the east side sandy silt loam Nord series, where you can see we have about 85 to 90% cover of the canopy. This particular field had the highest yield this year and is a beautiful example of what pistachio trees can look like on a non-saline, well-maintained sandy loam series. Now we'll jump across the valley to an orchard about 2 miles east of Coalinga in Pleasant Valley. Here we have 80 to 85% cover. You can see the eddy covariance, energy tower, measuring water flux on the left-hand side, and over on the right-hand side, we are measuring water content with a neutron probe, and you can see where we have the configuration of watermarks and tensiometers. This is a somewhat Excelsior sandy loam at this particular part of this 300-acre orchard, and has, again, beautiful looking trees. Now we jump back east to about 4 miles southwest of the Lemoore Naval Air Station to an area of lethant, alkali, sodic, clay loam dirt that's on the top of this slide. You can see in the left-hand picture, upper left-hand corner, a picture of the very long soil ribbon that indicates the pore structure and anoxic conditions of this area that is our most saline of all three spots. That has resulted in a very low rate of growth on these trees and death to a number of other trees from waterlogging. Just below that, you can see in the same field, this is only about 800 feet away, an area of lethant clay loam that's not near as sodic. It breathes a little bit better and has much better growth on the trees, but they're still quite a bit smaller than the trees of Coalinga and the ones near on the east side, which are really all about the same age. So this is sort of the bracket of the range of conditions that we're following across these three different monitoring demonstration areas. This slide really represents the initial start of this whole project, where we installed these energy flux, eddy covariance towers to essentially measure the water vapor leaving the orchard and get an idea of the variation of Pistachio ET from the non-saline to the saline conditions. This slide illustrates the difference in orchard ET from the non-saline soil up on the top to the more saline soil near the Lemoore Air Station. Data shown for 2016, 2017. We're still cranking 2018, 2019. But you can see there is almost a 40% difference in actual measured ET from the non-saline area to the saline field. These charts illustrate a somewhat surprising effect we had not expected. It shows that the cover crop planted to the west side pistachio orchard compared to the bare middles in the east side non-saline orchard produced a higher net radiation in the cover crop field. This resulted in driving more ET, possibly provided for more carbohydrate production, and in 2018 the net yield of the west side Coalinga field was very much superior to the east side yield. And in terms of water productivity, even though you use more water, the higher yield meant you got more crop per drop. This is not part of our irrigation demonstration, but we're trying to look more into this phenomena. Just the last few slides to quickly illustrate the data that we've been collecting. The top chart here shows the soil moisture tension in centimars calculated by watermark blocks compared to the tensiometers, which are the highlighted colors. Below that is the volumetric water content, basically percent inches per foot, as recorded by the Centec drill and drop capacitance probe. These data are for the west side field, which typically ran about one 48-hour set per week during the peak of the season. This slide indicates the difference in the amount of trunk shrink and swell during the day and subsequently at night for the saline site, that's the yellow line in the top, compared to the non-saline site, the blue line at the bottom. The Phytech dendrometer provides a plant-based tool to understand the increased stress that the salt load can impose on the pistachios. This is 2017 data. Our 2019 data is unfortunately inconsistent, but I would encourage you to look at the other PDF file that illustrates a comparison across all these sites for the different data that we have described in this presentation. This final data slide illustrates the difference in stem water potential from the non-saline site in the blue down to the highest seasonal stem water potential average that we measured in actually the semi-saline site. That's very similar to what the high salt load site was in the yellow line, but I believe the much smaller trees in that location produced a slightly less negative stress in the tree. The bottom line is salt makes a big difference in the stress that the tree experiences and needs to be considered when creating the optimal irrigation schedule. Okay, I'm basically done talking. The next 3 slides are text that you can read at your leisure to better explain what we're trying to do with this project. And you will know by the last page that we have not done the perfect job in supplying the real-time monthly web updates that were the original objective for this trial. The idea is to continue for 2019 and come up with feedback from you as well as providing information on these comparative data monitoring technologies.